This video is for loans and amortization payments. Amortization payments are a sequence of equal periodic payments to pay off the principal and the interest of a loan. And the equation is the same equation actually as that for ordinary annuity, but it's rewritten to solve for P, the payment. So P, the payment, is equal to large P, the loan amount, multiplied by I, divided by 1 minus 1 plus I to the negative n, where I is the interest rate per period, which is the rate over the number of periods per year, and n is the total number of periods. So example 1, find the payment needed to amortize a loan of $6,000 at a rate of 4% with interest compounded semi-annually in 24 semi-annual payments. So that means 2 years worth of payments. So we're finding small p, the payment amount. We know the loan amount, which is large P, 6,000, and then the rate is 4%. So that means that I, the rate per period, is 0.04 divided by the number of periods per year, since it's semi-annual compounding. That means 2 periods per year. So the rate I is 0.04 over 2, which is 0.02. Then we also need the total number of periods, n, which is 24 semi-annual payments. Then we have the information to set up this equation. So the payment P will be equal to the loan amount of 6,000 multiplied by I, which is 0.02, divided by 1 minus 1 plus I, so 1 plus 0.02, to the negative n power, so to the negative 24. And the payment amount per period is approximately $317.23. Example 2, fill out the amortization schedule for the first 4 payments on the following loan. A loan of $8,000 at an interest rate of 12% compounded monthly for 1 year. So an amortization schedule shows what payments are made, and of those payments, what the remaining principal is and what interest is paid off for the period. Before we fill in the table, we do need to find the payment amount for this loan with these conditions. So we know the present value of the loan is $8,000. The interest rate is 12% compounded monthly, so that's 12 periods per year, and for 1 year. So that means that we'll have 12 total periods. And the rate per period I is going to be R over M, so 0.12 over 12, so 0.01. So now the payment equation, we calculate the present value, 8,000, multiplied by I, divided by 1 minus 1 plus I, so 1.01, to the negative n, so to the negative 12. This is approximately $710.79 for each of these payments. So now in the amortization schedule, the amount of the payment for each of these periods will be that amount, $710.79. And this is just for the first 4 payments, so this schedule would continue until payment number 12, because there are 12 total payments here. So now in the schedule, the interest for each period, the interest percentage is the same. 0.01 is the rate, but the interest per period would be that rate per period multiplied by the principal at the end of the previous period. So the interest for this first period would be 0.01 multiplied by 8,000. So the first interest is 80. So that means that of the $710.79, $80 of it went to interest, and the remaining amount, that means went to pay off the principal. So that means that $710.79 minus 80, which is $630.79, went to paying off the principal. Now the principal at the end of the period means how much of the principal remains to be paid off. So that would be the principal at the end of the previous period, so 8,000 in this case, minus the principal that was paid off. So that means that the principal remaining at the end of this first period is $7,369.21. So now the next period, again, we pay $710.79, but now the interest is interest on this amount, the new principal, instead of the original $8,000. So that means for the interest for this period, we calculate 0.01 multiplied by the current principal. So that means that the interest paid this time is $73.69. Now we subtract the interest from the payment amount to get the portion that's paid to the principal, which means the portion paid to the principal this time is $637.10. And then finally, to get the principal at the end of this period, we subtract this previous principal minus the principal that was just paid off to get $32.11. And we continue in this way to fill out the whole table. So the only part that we calculate from the previous row is the interest, which we do 0.01, the interest rate per period, multiplied by the principal for that period. So 0.01 in this case times $6,732.11. So the principal this time is $67.32. Subtract that from the payment amount to get the portion that's paid to the principal, which is, in this case, $643.47. And then to get the principal remaining, we subtract the previous principal minus the principal that was just paid off. So in this case, we get $6,088.64. Okay, and we would continue in this way. So always to get the interest per period, we're doing I multiplied by the principal from previous row. So let's call that P sub PE for the principal at the end of the previous row, or the previous period. And this is whatever the payment amount is, which in our case was $710.79. And from that, we subtract the amount of interest, which I'll call capital I for interest. And then to get the principal at the end of the period, we use the principal from the row before, which we denoted PE, and we subtract this amount, the portion paid to the principal. And we would continue in this way for 12 payments until we get to 0. I want to point out a few things to notice. The amount of the payment is the same every time. The amount that is paid to interest is decreasing every time. So in that first payment, you have to pay more to the interest because the principal amount of the loan is larger. $8,000 is larger than the principal amount is later on. And then the portion of the payment that goes to principal is getting larger as we go through the payments. And that's just because the portion that's going to the interest in the column before is getting smaller. And then again, the principal that remains at the end of the period is going to be decreasing until it gets to 0 after the 12 payments. Example 3, a student borrows a student loan of $40,000 at an interest rate of 6% compounded monthly. Find the monthly payment for a payment period of 10 years, then find the total interest over the duration of the loan. So the present value of the loan is $40,000. The interest rate is 6%. Compounded monthly means 12 periods per year. So that means that the value of I is equal to the rate 0.06 divided by 12. So that will be 0.005. And then the value of N is the number of years, which is 10, times the periods per year, which is 12. So N is 120. So then setting up this equation for the payment. The payment is the loan amount multiplied by I divided by 1 minus 1 plus I, so 1.005 to the negative n power. Now this is approximately $444.08 for each payment. So that's the amount that will be made for each monthly payment for this student loan. Now if we want to find the total interest over the duration of the loan, we're going to calculate the total amount that was paid and then subtract the loan amount. So the total amount that was paid would be this payment amount multiplied by the number of times it was paid. So that means calculating $444.08 times n, which is 120. Now this gives $53,289.84. So this is the total amount that was paid over the 10 years. And part of that was paid was the principal for the loan. So now we'll subtract that principal to get $13,289.84. So that amount is the total amount paid minus the amount of the loan, so that gives the amount of interest over that period. There are other ways to compute this. This is just one way to compute the amount of interest paid.